Welcome parents, teachers and students. Today we are going to answer the question, why is experimental probability sometimes different to the theoretical probability? To fully engage in this video you may need a couple of resources. So find something to write on, something to write with and a six-sided dice. So to investigate this question, we are going to be using a six-sided die to conduct a chance experiment. But first, we need to calculate the theoretical probability. So, what is the theoretical probability of rolling a 3 using a six-sided dice? Remember, that theoretical probability is the number of favourable outcomes divided by the total number of possible outcomes. So pause the video now and calculate the theoretical probability using that formula. That's right, the theoretical probability of rolling a 3 using a six-sided dice is 1/6. You can also represent that as 17% or as a decimal, 0.16666 recurring. So, if we then do a chance experiment and roll the dice 10 times, will we end up with the same probability? Pause the video again and write down your answer. Is it yes? No? Maybe? Write it down now. So, I'm going to roll the dice 10 times. So we've got over here our theoretical probabilities, which is 1/6, and we're going to look at rolling a 3. So rolling a 3 is a 6, as we've calculated for the theoretical probability. We're looking at that line right there. So we're going to roll it once, and the first roll is a 1. So we've got 1 in number 1. We've rolled 1 once, and our theoretical we haven't rolled 3 at all, and our experimental probability is 0 out of 1. But our experimental probability is still 1/6. So we're going to throw the dice again. We've got 4 has been rolled, and the 3 has not been rolled, so it's got 0 out of 2 for its experimental probability. So we throw the dice again, we get a 6. So again, we've got 0 out of 3 for our experimental probability. We keep on going, get a 4, and a 2, and a 4, and a 5, and a 4, and a 6. Last roll, a 2. Our experimental probability is 0 out of 10. 0 out of 10? What? So for 10 trials, in none of those trials did we roll a 3. So our experimental probability is 0 out of 10. However, our theoretical probability was 1/6, a 6. So why is it 0 out of 10 when our theoretical probability was 0 out of 6? Is my theoretical probability wrong? Yes? No? Maybe? Why do you think this? Pause the video and write down your thoughts. So, my theoretical probability is still correct, and my experimental probability is also correct for 10 trials. Experimental probability only uses the results recorded to estimate what might happen in the next trial. However, that doesn't quite explain why my theoretical probability and my experimental probability was different. To explain this, we need to introduce the law of large numbers. The law of large numbers states that as the number of trials increases, so the number of rolls we do, the actual or observed probability approaches the theoretical probability. So the more trials you do, the closer your experimental probability will be to your theoretical probability. Let's test this law and try a larger amount of trials. Now, let's go back to our simulation. So it's going to keep on rolling the dice. And we're moving closer to 100 rolls. That is a large amount of trials. Of those 100 trials, we landed on 15 times. So we have the experimental probability of 15 out of 100, or 0.15. That is close to our theoretical probability. So we have a theoretical probability of 16, or 0.16667. It's been rounded up. And that's very close to our experimental probability of 0.15. So having a large amount of trials, having 100 trials, means that our experimental probability is closer to our theoretical probability. So we're going to keep on rolling and see what we find when we get up to 200. Of the 10 rolls that we did, none of those times landed on a 3. We didn't land on a 3 at all. However, as we keep on rolling, those 3s were rolled. So the experimental probability moved closer to the theoretical probability because the more trials you do, the closer you are to the theoretical probability. So, to ensure the accuracy of our experimental probability, it is important to conduct a large number of trials. A real-life example of this is when medication is trialed. It is important to have a large amount of participants, because the more participants you have in the trial, the better results you will have, because it's the average of all the results. For example, you give the medication to 10 people and one of those people becomes sick. You might consider this an anomaly because only one person became sick. However, if you have a trial of 100 people and 20 of those people become sick, it starts to become a pattern. So it's very important to do a large amount of trials in medication, when we're doing our chance experiments, because it ensures accuracy of results. So now let's have a look at our simulation. We've been rolling, we've had 200 rolls, and our experimental probability is even closer to our theoretical probability. We now have an experimental probability of 0.165. which is much closer to our theoretical probability of 0.166. So it proves that the more trials we do, the closer we will get, the closer our theoretical probability will get to our experimental probability. Thanks for watching.